Pythagorean theorem, Pythagorean theorem. I had to pop those things through to you guys. We had some problems with our dog. We had to take care of our cat. So, yeah, she didn't make it. But so we were out yesterday. Yeah, I'm sorry. So I apologize. I'm still kind of about all that. Okay. So I know that there's a few of you guys still owe me a test. We'll do that tomorrow. What I wanted to do today is just kind of reiterate what you did yesterday. Guys, I'm not talking over you. Enough is enough. So I want to reiterate a few of the things that we did yesterday. And then I want to make sure that we understand just a couple of new things, which really aren't that terrible. And then we'll go on from there. The few things that you had yesterday, and I know that there's some questions pertaining to some of those area formulas. The hope was when I was assigning some of those things through that, well, A, first of all, I hope that maybe you could have remembered some of them, or B, you had this crazy thing on your computer called the internet, you could have looked up the formula. But I don't know if Google comes through or not. But one of the things that you guys had over and over again was that. And this is finally the section that actually really does define it. What does that stand for? Pythagorean theorem. Okay. Now, where do you use Pythagorean theorem? Well, where's the only place you use Pythagorean theorem? More specifically, right triangles. Now, in right triangles, you always have one set of values that does not change, or one side length that never wavers. It's the hypotenuse. Where will the hypotenuse always be located in a right triangle? The longest side, and it's opposite the. Your hypotenuse is always the longest side length, and since it is the longest side length, it means it's also across from the largest angle. Well, remember, in right triangles, can you have larger than, or can you have more than one 90-degree angle, or one larger than 90 degree? Nope. It doesn't work. Now, that also means that the other two parts of the triangles were then just called legs. And it did not matter which was which, A or B. It does not matter at all. Now, one of the things that you will come across pretty regularly with Pythagorean theorem is that you'll have these things called simplified radical form. And that basically means that you're getting at, instead of saying that, hey, the square root of 12, well, when you type it in the calculator, it gives you what's called an exact answer at 2 root 3. So this is starting to get to the point where using the multi-view calculator becomes your best friend, because it rationalizes. It'll take care of these crazy values, and it will simplify those radicals for you. You don't have to do it on your own. Now, I know the first day on this, it's never been a big of a deal. There's not too many of them, but basically from here on out, we're going to use this thing called simplified radical form. Really, the only time we get away from that is when we're actually pressing buttons of trigonometry. So that's still a couple weeks away. Right. When you got into this, then, I know that there was one problem that I know that was not assigned, and I wanted to show you guys how this works before we get to the questions from things. If you flip your worksheet to 11, and I want to make sure that you guys understand how setups like this are going to work when we start working through Pythagorean theorem, because you're going to start to see more of this type over the next few days. Welcome, Joe. So, in number 11, it's showing you that you have a square. And that diagonal there, the way that you say that number would be 8 root 2. You should probably know that. In that right triangle, then, is the 8 root 2 playing the role of a leg or a hypotenuse? Good. So that means as you go through this, you have your a squared plus b squared is your c squared. Now, here's where you have to be very careful. And this is why I wanted to make sure I showed you guys this first off. when you square anything that has a number preceding the radical, a number in front of it, 8 root 2, 2 root 3, 9 root 4, or 9 root 5, whatever it could be, you always have to put that, before you put it in your calculator, you have to put that in parentheses. Because remember, when you are squaring something, if I take 3 squared, that means it's 3 times 3. Okay? So if I take 8 root 2 squared, it's technically 8 root 2 times 8 root 2. Now, you guys saw some little glimpses of things like this last year now for 1. Now, when you did this, if you recall, you would always take care of your full numbers first. What's 8 times 8?
You know.
Okay.
Everybody
said
16,
16, yeah. So that's not good. Okay. So we have so you have 8 times 8 is 64, and then you have the root 2 times the root 2. Now, I don't know if you remember this, but when you have two numbers being multiplied together, they both have a square root to them, it means they can go underneath one square root. What's 2 times 2? 4. And what's the square root of 4? 2. I'm sorry, what's that? No, I know where you're getting at here when you're talking about that. What were you saying though? Yeah. What I'm getting at here is this. When you have the square root of junk times the square root of junk. No, square root of junk times the square root of junk is just plain old junk. Junk squared is just junk. I'm glad you said that. So one of the things that you will learn, one of the things that you're going to learn as you get to element 2 is how the relationship between what are called radicals and their corresponding exponents work. Don't write this down. Those are equivalent statements. Joe. Oh. A radical is what we call an nth root. The nth root that it has is a 2. That means that it's being raised to a half power. When you square something, that's raising a power to a power. Well, there's rules about exponents. So when you have power to power, you would multiply your exponents. What's happening to 1? So the square root of x squared is x, because of the way that the exponents cancel themselves through. We're not solving it. Okay? It's not an equation, it's just a simplification. So what I want you to know is when you get to this, you have to use the calculator correctly. Because 8 root 2 squared does not equal the same thing as the quantity 8 root 2 squared. And this is the big thing that happens in geometry because you're not accustomed to having to use extra buttons. One of the things that you guys need to start to, this is why I wanted to stop and physically be here to explain to you why this has to be this way. When you're writing out your problems, you're working through your stuff, you know that you're taking the whole thing and squaring it. Your calculator doesn't. So when you're working with stuff like that, anytime you have a number in front of a radical, you have to square it, or you're doing stuff with it, you have to group it within parentheses so that way the calculator knows what you're doing. And this is the same thing that happens to any calculator. It doesn't matter if you've got the multi-view, graphing calculator, the Casios, the other, any one of them. If you don't put it in parentheses before you square it, you're automatically just going to be wrong. Right? So you just got to be careful with that. Right? Now, the rest of this problem then goes by pretty quick, but also, I want to make sure you see this. So we have right triangle, x, x, and it was 8 root 2, correct? Okay. So, obviously that's a right triangle. It is an isosceles right triangle. Okay with that? If it's an isosceles right triangle, what are the base angles? Correct. What do they both have to be? Good. So we get to this, probably we might start a very small amount of this on Thursday if we have time, is that this is technically one of the basis of trigonometry. It's what we call a special right triangle. We could spend weeks just working with special right triangles. In fact, when you get to algebra 2, when you work about what's called the unit circle, it's basically what you're using over and over again. Now, here we have x squared plus x squared is going to equal the quantity 8 root 2 squared. What's going to be x squared plus x squared? 2x squared. Remember, you're combining like terms, you treat them just like you would if it was x plus x, you get 2x. When you're adding things together, as long as they have the same base and the same exponent, you just add their coefficients. Right? So here you get 2x squared. Throw that in the calculator. We just did that. It was what, 128, I believe? Now you have to work with you got to work backwards. Okay? And that's where a lot of us make dumb mistakes. It's working with the order of operations in reverse. This is how you solve equations. A lot of times, and this is the same thing that happens with you guys, it happens with my Alpha 2 kids, it happened with my pre-calc kids when I taught that as well, is that you will make dumb mistakes because you go too fast. Remember, you have to work backwards via the order of operations. So you have to undo any subtraction. Is there any subtraction to undo? Is there any addition to undo? Is there any division to undo? Is there a multiplication to undo? Yes. You have to undo the multiplication before you do anything else. How do you undo multiplying by 2? So just like before, you're just working backwards via the order of operations. And now how do you undo squaring? Square root. Now, technically, shouldn't we have plus or minus here? Now, why don't we worry about the plus minus in this case? It's not so that it's not relevant. It's just that when you go back at the average, when I'll say it, can I have a negative second point? And that's where we get to. Okay, that's where we get to. We'll go from there. And that's what we're looking at being able to do. Okay? Yes, sir. No, please, John, go with this. Don't say stupid. Well, just tell everybody else. Maybe someone else has the same question.
So, like,
yeah. What do you mean? If this was 3x?
No,
Oh, if it was cubed? Or were you saying if this was x cubed equals? Oh, okay. Because there's a rule for that. You would have to take the cube root of that. And this is not relevant to what we're doing right now. But what this means are, what are 3 numbers that you multiply together that are the same to give you 64? When you have odd, what are called odd nth roots, which this is, your signs don't matter. Because if you think about it, what's -1 times -1? Not -1, it is +1. What's -1 times +1? -1. So I could take what's called the cube root of -1 and get -1 as an answer. It only has one solution, whereas square roots can have 2. Is that kind of what you were getting at? No, it wasn't. I was kind of guessing where you're at. You're kind of weird. I don't get it. I can call him that. So I went to college. What else you got on this worksheet then? What do you want to look at? Which one? Anybody else need one? You said 30, Miss Jackson, 31? That's close. So, now one of the things in here was dealing basically with some very simple areas. You had areas of triangles, you had areas of rectangles. Remember, the area of a triangle you should all know half base times height. If you didn't know it, you could have Googled it. Right there. I think it was also written on the whiteboard. So, when you're trying to figure out your bases and heights for triangles, remember that's always where the right angles are created, which means we're missing one of them now. So in this case here, I am missing one of my side lengths, so I have to use Pythagorean theorem. That side length that I'm missing, is it going to be a leg or is it going to be a hypotenuse? So I'm just going to call that x. So I have x squared plus 7 squared is 10 squared. Okay. If we do this correctly, we're going to get x squared plus 49 is 100. Subtract it over, you get to 51. Now, in order to solve for x, we then have to press the square root button. So if you take the square root of 51, I do not believe that it simplifies to anything. So you probably got square root of 51, correct? Good. That's fine. That's exactly what you should get. So if I put that in here, now I have a base and a height of 7 and the square root of 51. So using the formula, 1/2 of 7 times the square root of 51, your calculator, if you type it in just like that, would spit out 7 root 51 over 2. And that's an exact answer for half of 7 is 3.5. 3.5 root 51. What's that? It's just the formula for the area of the triangle. It's just substitution right there. If your calculator spit it out in a decimal form, you should have gotten 24.99, depending upon how your calculator solved it out. Okay? So any one of those are all equivalent. Obviously, I wasn't around to explain to you that I would like the radical form. Radicals. Radicals, because the more we get used to seeing the radicals, the easier everything else becomes. What was the other one you wanted to see? I heard 20. Yes, 30? Yes, ma'am. Yeah. It just looks weird, but that's what you call an exact answer, and that's what we're trying to get work to. All right. Now, in this case here, you could have done one of two things. One of the things you could have done here is recognize what the shape is. What is that? Correct. Correct. Trapezoid. The trapezoid. The reason that it's a trapezoid is because it's got one set of parallel sides. The reason I know that they're parallel is if you think back to chapter 3, when you have a right angle and a right angle, it means the two spots that they created that have to be parallel to one another. So you can do the area of a trapezoid, which I don't know is on the board or not. You could have Googled. 1/2 the height times the sum of the bases, or create what's called a composite figure. A composite figure means a rectangle and a triangle. Okay. Just by redrawing it, you can do that. So that moves this 14 over here as well, and it moves the 11 down here. Trapezoid. About what? I'm getting there. You have a rectangle and a triangle. Add the areas together. Yeah. If the whole base is 20, this much is 11, how much is left for here? There you go. Base times height for a rectangle. Half the base times height for the triangle. Way too much talking. For the amount of questions we're getting on this, you guys should probably be a little bit more quiet. Okay. What happens here, guys, is that when they start these things through, they give you very straightforward shapes that create right triangles, which means everything can be broken down into triangles, or they can be broken down into rectangles and triangles. Those are composite figures, figures that are made up of more than one shape. And they're not trying to make them any more difficult than that. And you don't have to worry about being a trapezoid or a rectangle or things like that. Oh, I'm sorry, you don't have to worry about knowing all those formulas, because as we get going into more of this stuff, I'm never going to make you memorize formulas. You have to know how to use it. Okay, that's what we're going to get towards a lot more. Okay. Did I hear say someone about 32? Was it, or did I do that? 22. This is giving you a leg and a hypotenuse. So you have a leg of 8 and a hypotenuse of 16. In order to find the area of that, you got to find the missing leg. Call it x. Come on now. Throw in the calculator, you take 16 squared and subtract the 8 squared. You get 192. Your calculator will simplify that radical by hitting second square root of your answer. Remember how we've used the answer button pretty regularly as up to this point? There's an answer button. The answer button, Joe, come on, put that away. The answer button is used for the last time something has been entered for. That way you don't have to re-enter stuff. So if you type in the square root of 192, what does it simplify out to be? What does it say? 8. Good. 8 root 3. The answer button is you hit second negative symbol. So this gives you your value here of 8 root 3. Now you have your base and your height. Half base height. 32 root 3 something squared would be your official answer. Okay. Do bases and heights matter which one's which? Nope, not at all. Just because they're moving through with the perpendicular one. No, right into it. One more, because I want to do a couple other things real quick for we're out of time. Huh? You gotta type the other stuff in. You gotta type 16 squared minus 8 squared. That's fine. All right, so the last little bit then deals with this. What is that called again? Does anything change if I write it going backwards? The reason why I'm going to write that backwards is I want you guys to remember some stuff from way back in chapter 3. We talked about what was called the converse of a statement. If, then, say it backwards, then if. Remember that? Yeah. So if you have a right triangle, then the sum of the squares of the sides equals the hypotenuse squared. That's technically the Pythagorean theorem. So if you have a right triangle, then a squared plus b squared has to equal c squared. And that's what we're getting at. If I say that in reverse, if c squared equals a squared plus b squared, then you have a good. So what happens is we use this as converse, a backwards statement. If this happens, then it's a right triangle. But the real reason why they say these backwards is because sometimes it doesn't equal the sum of the sides. Sometimes it doesn't equal a squared plus b squared, which means there's two other options. It could be larger, or it could be smaller. By knowing the three sides of a triangle, you can tell what kind of triangle you have. It can be right, it can be obtuse, or it can be acute. Take a guess why they say if c squared is bigger than a squared plus b squared. Which one do you think it is? Obtuse or acute? Obtuse. That's why they write them first, because you think bigger, you think obtuse. If it's smaller, then it is acute. Okay. Now, the only other tricky part to this is being able to tell which number in a group of 3 is the largest. I know that takes a lot, but I think you could probably figure it out. For example, if I give you 12, 13, and 5, which one of those 3 numbers would have to play the role of the value of c? 13. Because 13 is the biggest. Yeah. So when you put these things through, you have to figure out which one is the largest. So I check it. What is 13 squared's relationship to 5 squared plus 12 squared? So I take my trusty old calculator out, and I type in 13 squared, and I hit the button that says equals. And then I take my trusty calculator out, and I press the button that says 5 squared plus 12 squared. And I get? So, are those two numbers equal? So therefore, what kind of triangle is it? Correct. That's what you're doing. That's what you can do with the Pythagorean theorem. The Pythagorean theorem allows you to tell what type of a triangle you have before you know what kind of a triangle you have. So you know. If I take if I take 2 root 3, 2, and 4, I have to figure out what to do with that 2 root 3. I don't know what that is in terms of if bigger than 4 or smaller than 2 or bigger than 2. I don't know which one of those is the largest. Do you know how to check decimal equivalents on your calculator? If you type in your calculator right now 2 root 3 and hit enter, watch what it does. It just says, same thing, it says 2 root 3. Now, If you have it, it just comes back up as 2 root 3. You hit that double arrow button. I heard you say arrows. The double arrow button down, the one right above enter, I believe. And you get what for a decimal? Now, so it gives you a decimal equivalent. It's called a decimal equivalency. 3.4-ish. So is 3.4-ish bigger than 4 or smaller than 4? Smaller than 4. So now, which number in this sequence has to be the largest? 4. So you do the same thing. That's about as goofy as this gets. What do I have to do with that 2 root 3 when I square it, though? What do I have to put in for my calculator? Parentheses. I think it's just parentheses. Put those together, 4 squared is how much? 16, not 8. What's 2 times 2? 4. What's 3 times 3? Square root of 9 is? I didn't know if it was up there. So you get 4 plus 12, which is, so therefore, what kind of triangle is it? Right. Right. This actually is another one of our special right triangles. What's that? No, you're done. That's your answer. Yeah, let's have 8. What's 4 times 8? It's not 3 3.
No, I just did it.
What's that?
No.
When you put that in your calculator, if you put parentheses 2 square root 3 squared. You got it? That's where I'm getting at. Some of these numbers you're going to start to recognize real quick. 2 root 3 squared is always 12. You're going to know 2 root 2 squared is always 8. Yes, ma'am? 8.1 still? I don't know. Did I agree there? Yes, sir. You might not have to. It doesn't hurt to try it. That way, once you start realizing, when you learn more, I won't say learn more, but when you learn approximations a little bit better, you won't be doing it as much. But it doesn't hurt to check it. That way, you know which one's which.
Wow. I didn't know.
Well, that's why.
Whole number now?
Yeah, I mean, if you think about it, if you have 4 and 2, which one's bigger? 4. Here, 2 root 3, I don't know what 2 times the square root of 3 equals. That's why I'd have to go to my calculator and just type in 2 square root of 3 and hit enter. Mine, because I'm using my 84 right now, mine automatically spits out a decimal. Yours says 2 root 3. Then you'd have to hit your double arrow button to see what that is. So once you see that, oh, that one happens to be smaller than 4, so I don't have to worry about it. So right away, when you get to this point, you can just do this. It doesn't answer square, it tells you what it is. So there's little tricks that you'll catch on to, because as we go through a lot of the calculators, this is why it's so important that we all have calculators when we come to class. We use them all the time. Okay? Tell me what type of triangles these are. All right, one of them says 8, 4, and 8. Let me just rewrite that. It's easier to see. Try those out real quick. We'll go from there. That's the thing, you can't automatically assume. That's why you got to figure out which one's which. Because remember, we don't want to assume, right?
Yeah.
Because what is it there in math? There's no ass in math. So we don't want to assume. You can do stuff like that in high school. You can't do that. Cadu would have done that. Makes me feel old. Mr. Nelson back there. Yeah. He actually had for a teacher in high school a guy I went to college with that went all myself, Sev, and his old former teacher, Mr. Cadu. The three of us all went to school together, so it's kind of weird that four guys in a classroom with me now, and he's taking classes from Sev, and he knows Mr. Cadu, who's another math teacher who's just like me but shorter. Am I right? Yeah, we're pretty much the same person. He's got a crummy little goatee going where same bad jokes, same mannerisms, and yelling at children. And what's that? No, they called me, I was tall Jeff, he was short Jeff in college. So, square root of 8, is that bigger or smaller than 6? So I check it, 6 squared versus 4 squared, it's square root of 8 squared. What's 6 squared? 6. 4 squared? The square root of 8 squared, 8. What's 16 and 8? Is 24 bigger, or is 36 bigger, smaller, or equal to 24? Therefore, it is. That's what you're doing, guys. You're checking to see via your calculator for your approximations prior to doing the work. Square root of 13, is that bigger or smaller than 12? So? What's that, Joe? 12 squared, how much? 10 squared. The square root of 13 squared. 13. So this becomes 113, which makes this do those, please. So the textbook, too, I would suggest you make sure you screenshot it before you get out of here. Just one page off of it. It's really quick. The stuff that's out there is very similar to what we did yesterday and some of these. Okay? We'll go up from there tomorrow. I'm sorry, I couldn't hear you. What I'm going to do, yeah, if you didn't get a chance to finish that one through yesterday, I hope that you saw enough of it to be able to knock the rest of it out tonight. We will stay with these two assignments together tomorrow. Yes, you didn't get a couple of those area ones or you want to wrong fix them real quick. We'll do these. These shouldn't take very long. All right. Yes, ma'am.